In this video, I'm going to explain how to find horizontal asymptote of a function. When you have a function y equal to f of x, in order to find its horizontal asymptotes, you have to find two limits. Number one is limit of f of x as x approaches positive infinity. And if you find a real number as the solution, like L, then in that case, you say y equal to L is a horizontal asymptote. The second limit you have to evaluate is limit of f of x as x approaches negative infinity. And if you find another number like m, then you say y equal to m is another horizontal asymptote. So then in that case, f of x has two horizontal asymptotes. So then based on this definition, a function can have maximum two horizontal asymptotes. Let's look at one example here. For example, if your function f of x is square root of x squared plus 1 divided by 2x minus 1. To find the horizontal asymptotes, I'm going to start with finding limit of f of x, which is the square root of x squared plus 1, over 2x minus 1 as x approaches positive infinity. Okay, now the usual technique is to substitute infinity. That's what we call direct substitution. If you substitute infinity in this equation here, the answer is going to be infinity over infinity because in the numerator, you're going to get infinity squared plus 1 divided by 2 times infinity minus 1. And compared to infinity, 1 is a small number, so that infinity squared plus 1 is technically infinity squared. You can just ignore 1. And square root of infinity squared is just infinity. And then denominator, minus 1 is small compared to 2 times infinity. Therefore, again, the answer is going to be infinity, and infinity over infinity is undefined. So to find the solution for this limit, I am going to factor x squared under the square root. So it's going to be x squared 1 plus 1 over x squared. And then for the denominator, I'm going to factor out x. So 2 minus 1 over x as x approaches infinity. Now, something to remember is anytime you have the square root of x squared, the answer is absolute value of x. So then this limit is equal to limit of absolute value of x, square root of 1 plus 1 over x squared divided by x times 2 minus 1 over x as x approaches positive infinity. Now, when x approaches positive infinity, so then x is a positive number. So then inside this absolute value, you have a positive number, and absolute value of a positive number is the same as the number itself. So then you can just remove the absolute value and write this as limit of x times the square root of 1 plus 1 over x squared divided by x times 2 minus 1 over x as x approaches infinity. When x approaches infinity, then 1 over x squared term here is going to be really small because you're dividing 1 by infinity, and that the answer is going to be 0. And same for 1 over x. When x approaches infinity, that is going to be 0. And you can also cancel x and x here. So then you're left with square root of 1 and 2 in the denominator. So the answer is going to be 1 half. So this 1 half is one horizontal asymptote. So that is a horizontal asymptote. Now, another limit you have to find is limit of square root of x squared plus 1 divided by 2x minus 1 as x approaches minus infinity. So again, if you substitute infinity, the answer is going to be infinity over infinity, which is undefined. So then I'm going to factor x squared from under the square root. So everything is going to be similar to previous step. But when you get to this point where you have limit of absolute value of x, square root of 1 plus 1 over x squared, x times 2 minus x as x approaches minus infinity. So then in this case, since x is going to negative infinity, so then x is a negative number. And therefore, inside this absolute value, you have a negative number. And when you remove the absolute value, you must multiply x by a minus because the output for an absolute value must be a positive number. So that's going to be a limit of minus x times the square root of 1 plus 1 over x squared, x times 2 minus 1 over x approaches negative infinity, and 1 over x squared, when x approaches infinity, is 0, 1 over x is also 0, and then when you cancel minus x and x, you're going to get a minus 1 on top, and then a 2 in the denominator. So then the answer is going to be minus 1/2. So this is the second horizontal asymptote for this function.